Ionic bonding is formed between a metal and a nonmetal. So that's something from the left side of the periodic table joining up with something from the right side of the periodic table. In the case of this first level, we're going to start off with a very simple atom. We're going to start off with sodium. Okay, so if I put sodium over here, you'll notice that sodium has a positive charge, and the reason why it has a positive charge is because it loses one electron, and so it's going to become something called a cation. Chlorine has a -1 charge. Has a -1 charge. The reason why it has a -1 charge is because it gains one electron. You'll recall that from our ions activity that we did. And so now they have opposite charges. Sodium has a +1, chlorine has a -1, and it's called an anion. Now, they become more stable by losing and gaining electrons, but they become more reactive once they have a charge. So now they're going to want to react with each other. And so now what we're going to do is we're going to activate the rings by turning them on. So that's going to be positive and a negative. And you'll see that they are attracted to each other and they form a bond. So they're bonded together right now. And we have our first compound, which is sodium chloride. The reason why there's one chlorine and one sodium is because each has a exact same opposite charge. So there's +1 and a -1. So you only need one of each. So the formula for the compound that we'd form is NaCl, sodium chloride. Okay, so it's a 1-to-1 ratio. Are the charges paired? Yes. We get sodium chloride. It looks like this. It's a crystal structure. And the formula mass, we could look up the formula mass online. So that's how you complete level 1. Okay. So now what happens if it's not just a +1 charge? Well, if it's not just a +1 charge, sometimes atoms gain or lose 2 electrons. So if you gain 2 electrons, you're -2. If you lose 2 electrons, you're +2. So in the case of magnesium and oxygen, magnesium will lose 2 electrons to become +2. So we're going to activate these 2 rings by clicking on it twice. We're going to activate these 2 rings by clicking on it twice. And because magnesium is +2 and oxygen is -2, they have perfectly opposite charges. We only need one of each. And when we bring them closer together, once I turn on the charges, they attract and form a bond. And so the formula for magnesium oxide is MgO. It's MgO because we only have one of each of these 2 atoms. Now, sometimes I'm going to allow you to you'll complete this level on your own. Sometimes things are not perfectly opposite. Sometimes you have a difference in charges, and we'll get to that in right now. In this level. Okay, so sometimes it's a 2-to-1 or a 1-to-2 ratio. So in the case of, let's say, for example, I want to make an atom that's 1-to-2. That means 1 positive and 2 negatives. That means I need to have a positive ion that has a +2 charge. 1, 2. And a negative ion that has a -1 charge. Now, if I bring these together, it doesn't quite form a bond completely. And the reason why it doesn't form a bond completely is because I don't have enough negative charge to cancel out the positive charge. So I need an additional fluorine ion here. Notice that they repel each other, but at the same time, they are both attracted to magnesium. And so now that the positive charges and the negative charges cancel out, I have my next molecule, which is magnesium fluoride. Okay. Now I need to make one that's 2 to 1, which means that I need a negative charged ion that's -2, which would be sulfur, and a positive charged ion, which is +1, and that would be potassium. So if I activate these rings, this -2, that +1, notice they attract to each other. Activate that one, and it will attract as well. And now I have my next atom, which is a 2 to 1 ratio, 2 positives to 1 negative of potassium sulfide. Drag it and put it here. So the goal in the end for ionic compounds is to make the net charge equal 0. You want your positive charges and your negative charges to cancel out. Okay. Now, when it comes to something called a polyatomic ion, I don't want you to get all confused about a polyatomic ion because it's nothing more than an ion. It is just a group of atoms that make up a charge. So when we do polyatomic ions, for example, let me restart this level so you can't see it. Restart the level. We're going to make a compound that's, let's say, 2 positive to 1 negative, 2 positive to 1 negative. All right. So 2 positive to 1 negative. That means that my 1 negative has to be -2. And in order to make this cancel out and have a 2 to 1 ratio, I have to have positives that are +1. So now you'll notice if I activate the rings, that potassium is attached to the sulfate. If I activate this ring, that other potassium will be attracted to the sulfate. And now I have a compound that's K2SO4. The charges will disappear. And it's 2 to 1. Okay. The formula for this would be K2SO4. Okay, this is showing me a 2 to 1 ratio. 2 to 1 ratio. All right. Now, let's say I want to make one that's 3 to 1. Well, if I want to make one that's 3 to 1, I'm going to have to use my phosphorus, and it has to be 3 to 1 of the same element. So you can't mix and match the hydroxides with the potassium. So in this case, I'm going to use 3 potassiums. 1, 2, 3. So this is going to be +1. This is going to be +1. My mouse is not working again. There we go. So now they're going to be attracted to each other. I'm going to end up with K3P. So the formula for this would be K 3p with a 3-to-1 ratio. And then you'd have to make the last one on your own.